We're focusing on the study of early onset Alzheimer's disease, which begins before the age of 65, and in particular in familial forms of the disease, which are dominantly inherited. In such families, the disease onset can be as early as 50 or 40 or even 30. In such cases, there are familial inheritance, which is quite frequent, and in such families, rare mutations in one of three genes, which are APP, SEN1 and SEN2, can be identified. The disease can be as early as 50, 40 or even 30 in families with a mutation within APP, SEN1 or SEN2. What we learned from these mutations is that all these mutations are responsible for the increased aggregation of the A-beta peptide in the brain. And this is the key event leading to the pathology. That is why current strategies are focusing against the secretion, against the aggregation of this peptide in the brains. And current strategies are focusing on presymptomatic carriers, which are the offspring of a proband carrying a causative mutation, which has a 50% risk to be a carrier. And if he or she is a carrier, he or she will develop the disease in the future. And we can propose them, in the context of a clinical trial, a preventive strategy against the A-beta secretion. If these strategies are effective, it will definitely change the life of these families. But beyond these results, we can learn from this small subset of families and identify at high-risk individuals in a more general population to allow preventive strategies for a larger population. And that is why we are focusing on the identifications of new genes and new variants that confer a high risk to develop the disease by using whole exome sequencing.